All right, welcome Algebra 2. We are reviewing for the test. Chapter 6 is split into two tests because it's kind of a long test, so it's going to be split into 6.1 to 6.4. So that's what this video is reviewing. It'll be 2 days of review, so we'll get as far as we can today and then pick it up on the next lesson. First part, 6.1, one of our objectives is to evaluate radicals. And the key to this is knowing how many answers. So all of these things you can just type in your calculator, right? Like, I don't know, third root of negative 27. So I can do 3 math, x root is number 5, negative 27. All right, and it'll get me my answer of 3. All right, so all of it you can do on the calculator, but the trick is to know how many answers. So there's these odd ones, and they both have one answer. So these both have one solution. Right, any odd root like a third root or a fifth root, and again, those are the indexes, like a third root, a fifth root. Okay, and then even root will either have two solutions or none. So if it's positive and even, two solutions. So like here it'd be plus or minus 4. And here you'd have no solutions. All right, this has, I guess I should say no real. It has two imaginary answers, but if it's negative and even, you have no real answers. And again, that's any even root is like a square root or a fourth root. Sorry for the poor handwriting there. My computer's freaking out here. But any even root, you'll either have two or none, depending if the radicand, number underneath the radical is positive or negative. All right, so here's 3 questions for you to try based on that information. Reference that chart. Hopefully you got it somewhere in your notes, but reference this as you complete these questions. Okay, so the first one is going to have one solution because it's odd and negative. So you can type it in your calculator. Sorry, my computer is really struggling right now. But it's going to have one solution. I can get this thing to work here. All right, and it's just going to be negative 4. And again, if you're not sure, type that in the calculator and you'll see. This fourth root is an even and positive. So I know there's going to be plus minus, and then just type it in your calculator. So you can type the 4 first, math, x root, and then whatever that number was, 1, 4, 6, 4, 1, I think. All right, and so your calculator will tell you that it's 11, but we've got to remember that it's both plus and minus. This would be plus and minus 11. Last one is negative and even, so this one has no real solutions. Again, sorry for the poor handwriting. My computer apparently can't handle all the things I'm trying to do right now. So that should say no real solutions. Okay, another couple for you to try, just simplifying in 6.2. Definitely pause the video and try these. Just reference, you can have this little chart out when you take the test. So it's our perfect squares, thirds and fourth powers. So you have that available to you. But yeah, definitely try these, right? Don't just watch me do them. Try them before watching the answers. Okay, so the rule with radicals is you can smash them together and pull them apart as long as the indexes are the same. So in this one, I'm going to smash it together and make a third root of 6 times 4. And then say, oh, are there any perfect squares? So I'm going to break it back apart into 2 radicals, except this time one of them is going to be a perfect, not square, sorry, perfect cube number. So for 24, the only one that was a possibility is 8, but we're in luck because 8 times 3 is 24. So now the third root of 8 is 2. All right, and then we have the leftover third root of 3. All right, so that's a simplified version of this multiplication question. Second one here, we just want to split it. All right, it's already one radical. So we're just going to break it, and we want to put the perfect stuff up front and then the non-perfect stuff in the back. And on our cube list, 216 doesn't work, but 125 evenly divides it. So 125 times 2. And then the cube root of 125 is just 5. So you have 5 times the third root of 2. Okay, and so this skill of being able to simplify is a huge part because many of our add, subtract, multiply questions involve simplifying your answers when you're done. So this first one was technically like a multiply question, but in order to finish it, we had to simplify. All right, so a couple more simplified questions for you to try. All right, first one, this is a square root, so if nothing's written there, it's a 2. And we don't have to do any splitting here because the square root of 16 is 4. And then this 8 is evenly divisible by 2. So you just have 4x to the 4th, and that's it. Okay, the second one, not as lucky. 16 is not a perfect cube list, right? If you reference that list that was seen on the previous slide, right? So we look at our cube numbers. So 16 is not on there. So we're going to split it into the perfect part and then the leftover didn't get asked to the dance part back here, right? The Mr. Westpatel leftover part. So for 16, there's an 8, right? 8 times 2, because 8 is a perfect cube. And then for x to the 7th, if it's not divisible by 3, I just count backwards. So if we go to x to the 6th and x to the 1st, that 6 is divisible by 3. So we're going to put 6 x's here and then 1 in our leftover so that we still have 7 like we did at the start. Now clean up the perfect part. Cube root of 8 is 2, and then 6 is now divisible by 3, so it gives us x squared. And then our leftover part, we've got a third root of 2x. All right, and that's it. Simplifying radical expressions. All right, let's have you do one more because that's such an important skill for this test. So pause the video, try one more here, make sure we're okay. All right, so it's a square root this time. So I'm going to make it into the perfect and non-perfect roots. 48, just find a perfect square that divides it, and you want to start high. So 49 is too big, but 36 doesn't work, 25 doesn't work. 16 does though, right? So we can split the 16 in 3. Also 4 works. 4 is a perfect square that divides 48, but you want to use the bigger one of 16. X cubed, so 3 is not divisible by 2, but I can split it, and I count backwards from 3 and say, well, I can put 2 here and 1 here, because then it will evenly divide with the index. Y to the 4th is already good, so we're just going to put it in the perfect spot, nothing to split there. And now just clean up our perfect stuff. So square root of 16 is 4, and then divide these by that index, so we'd have x to the 1st and y squared, and then we'd have a third root of 3x left over. All right, and that's our simplified expression. All right, from there, one of the things we do is multiply these binomial. This is a binomial deal. So see if you can multiply them together and get one of our answer choices here. All right, here you go. So we're going to FOIL negative 8 times 6, negative 8 times root 3, negative root 3 times 6, and then negative root 3 times positive root 3 would be negative root 9. So we have negative 48, and then these combine to negative 14 root 3's. They're like terms. Square root of 9 is 3. Okay, and then the minus 48 minus 3 is negative 51. And then we still have negative 14 root 3. All right, so that's our cleaned up version. Looks like answer A is the right choice. All right, another one for you to simplify. And the deal here is we don't want any radicals in the denominator. So you got to figure out how to get rid of that radical in the denominator. All right, so the trick is you multiply by the conjugate. because the conjugate will clean up the denominator and make it really pretty. So we're going to multiply the top and bottom by the conjugate, which is the same expression, same binomial, but just flip the sign in the middle. So this was a positive and flip it to a negative. Up top, we're just going to distribute. And so we'll get, oh geez, that's brutal. Let's try again. We will get 66 minus 11 root 3. Okay, and in the denominator, I'm going to FOIL. So 6 times 6 is 36. 6 times root 3 is negative 6 root 3. Positive root 3 times 6. And then root 3 times negative root 3 would be negative root 9. All right, so with conjugates, the magical part is those middle things cancel out. And then we're just left with 36 minus 3, square root of 9 is 3, so we get 33 as our denominator. Right, and if you get there, that's pretty good. Please know that all of these parts are divisible by 11, so you could clean it up to 6 minus 1 root 3 over 3 would be a little bit simpler of an answer. All right, so this is a second rationalize the denominator type. So on the previous one, we multiplied by the conjugate, top and bottom. So on this one, you got to figure out what do we got to multiply to wipe out the radical in the denominator. All right, now that you've had a chance to try it, with a third root, you're going to multiply by 2 more third roots, which is the same as the denominator. So third roots of 2. And what you'll end up with on the bottom there is a third root of 2 cubed, and then that just wipes out to 2. So if we multiply the top and bottom by third roots of 2, sorry, I forgot to write it up there, but do it twice, the denominator becomes 2, which is what we want. We got rid of the radical down there. And the numerator, just do third root of 7 times third root of 2 times third root of 2 gives us a third root of 28. We can check, are there any perfect cubes that divide 28? And I don't think there is. Right? 8 doesn't work. 27 doesn't work. So that's our cleanest answer where we got rid of the radical in the denominator. All right, and that's it for day 1 of our review for 6164. Again, those last two are pretty tricky, but to rationalize the denominator, if it's a binomial, you multiply by the conjugate. If it's a single part, it kind of depends. You've just got to multiply, look at what the denominator is and multiply by that. In this case, we had to do it twice because it's a third root, and then it got wiped out. All right, that's it. There'll be a second video reviewing some more information. Thanks for watching.